is Jahal Lee.
My name is Tyler McNellis.
My name is Anderson Corey.
My name is Salman Kumar.
And we are the IMSE Group 8 for Senior Design, working with Futureline Manufacturing.
The project we are working with is in spring 2019 with Futureline Manufacturing, which is a truck body manufacturer located in Cedar Rapids, Iowa. They produce American-made customizable aluminum and steel truck equipment, bodies, and accessories. The project is focused on Class 8 dump body, which was recently overhauled, and some formal processes need to be documented. Therefore, our target is to make Futureline Manufacturing have a better grasp on overall production costs and the time it takes to build their Class 8 dump body.
The objectives for the group were 1. Improving the overall labor efficiency associated with the dump body build line by 15%, 2. Increasing the amount of time spent welding by 50%, and 3. Investigating reducing the cost of welding by 20% through a capital investment.
For the CSA, we did a work sampling study, workplace organization analysis. We performed some welding time studies, and we got some spaghetti diagrams. For the work sampling study, we had 4 days of studies completed, and a total of 16 hours were observed. Here's the pie chart for the work sampling study of all the operators, and the 2 notable things are the transportation waste, which comes from walking, which is 21.8%, and the non-value added time, which is 22.4%. And for the workplace organization analysis, there was a lack of tools, and tool sharing was occurring. So a solution would be a need for basic level of tools, so tool sharing never occurs. And there were build parts that were being held at a central location, so they should have tool stations at every station. And also there should be improvement in the utilization of their forklifts, and also have a build parts cart. For the welding time studies, we all shadow welding employees when welding was a sole task that was being performed, and we performed a weld test to get the baseline welding rate, which comes at 13.84 inches per minute. And for the results of the welding time study, the value added time was 73.1 minutes, and the non-value added time was 81.9 minutes. And as a percent, they both are basically 50-50%, except for the non-value added time being a little bit more. And there was a seam weld time dump body. No, there was a welding study performed on a seam weld time dump body where there were 154 total feet of in-position seam welds, and the total time it took for the seam welds were 2.233 hours of the in-position seam welds. For the spaghetti diagrams, the purpose was to reduce the transportation waste that was occurring in the plant. And the analysis was on the milling area, the welding area, the final assembly area, and the product operators. And the team members walked with operators with the measuring wheel that's pictured in this slide. And here's a sample spaghetti diagram that was performed on an assembly operation.
Our solution for Futureline Manufacturing was to create a standard operating procedure for the Class 8 dump body line. With a standard operating procedure, it would create a standard work process, increase ergonomics of workers, reduce the movement within the build process, reduce variation in errors within the build process, reduce number of steps for assembly, reduce assembly time, as well as providing a training tool and introducing 5S and workplace organization. As for ROI, if all our objectives are met, including achieving 15% labor increase, we would see an $85,000 ROI. Achieving an increase in employee time spent welding by 50% would result in $31,000 of ROI. And implementing a seam welder would be $7,500 of ROI, for a total of $125,000 if all objectives are met and implementations are in place.